In this video, we'll be looking at the angles formed by chords and secant lines intersecting inside, outside, and on circles. To help you get the most out of this lesson, please pause now and open your copy of the capture sheet linked above if you've not already done so. You'll be asked to take notes and answer questions on the capture sheet during this video. You may also want to stop the video from time to time to interact with the GeoGebra applet posted on this page below the video to recreate what is happening in the video. By the end of the lesson, you'll be able to do three things. One, describe the relationship between the measures of angles formed by secant lines intersecting inside circles and the arcs they intercept. Two, describe the relationships between the measures of angles formed by secant lines intersecting outside circles and the arcs they intercept. And three, be able to apply those relationships to solve for missing angles in circles intersected by secant lines. In the discussion board, you explored measurements of angles related to the red secant lines, lines ED and line DF, by moving blue points B, E, and C. And you may have noticed that there's a relationship between the measures of the two vertical angles and the two central angles. The sum of the measures of the vertical angles was always equal to the sum of the measures of the vertical angles. In this case, 166 hundredths degrees. Since the vertical angles have the same measure, in this case 50 and 33 hundredths degrees, the measure of each vertical angle is half the sum of the measures of the central angles. Let's see this in the GeoGebra app. No matter how we move these secant lines, or where they intersect, the measure of each vertical angle is always half the sum of the measures of the two central angles. And since each central angle is the same measure as the intercepted arc, in this case, the measure of arc ED is 66 and 33 hundredths degrees, and the measure of arc FG is 34 and 33 hundredths degrees. So the measure of angle DCE is equal to the measure of angle FCG, which equals half the sum of the measures of arcs DE and FG. Pause the video here and fill in the blanks on your capture sheet, showing the relationships between the vertical angles and the two arc measures. We can generalize this to any circle with two secants or chords intersecting inside the circle. Let the measures of a pair of vertical angles at the intersection be n degrees. Call the measures of the intercepted arcs x and y. It will always be true that 2n equals x plus y, and that n is equal to x plus y divided by 2. Pause the video here and record this formula on your capture sheet. The same relationship holds true if you consider n to be the measure of the other pair of vertical angles, and x and y to be the measures of the arcs intercepted by those angles. It is still true that 2n is equal to x plus y, and that n equals x plus y divided by 2. Now, what happens if the secant lines intersect outside the circle to form a pair of vertical angles of measure n? Notice that the secant lines intercept the two arcs, a larger arc, whose measure we call x, and a smaller arc, whose measure we call y. What is the relationship between x, y, and n? Let's go back to the GeoGebra output again and look. We start by seeing that the secant lines intersect inside the circle. And we notice that the combination of the two vertical angles, DCE and FCG, are the same as the sum of the two arc measures, defined by DAE and GAF. What happens as we move C towards the edge of the circle? We see that the measure of one arc gets smaller and smaller, approaching zero. And as we move the intersection outside the circle, we notice that the sum of the vertical angles, DCE and FCG, is no longer the same as the sum of the central angle measures. What do you notice about the relationship now? Pause the video here and record your observations on the capture sheet. We see that the sum of the measures of the two vertical angles is not equal to the sum of the measures of the central angles, but rather the difference. So, when secants intersect outside the circle, 2n is equal to x minus y, and n is equal to x minus y divided by 2. Pause here so you can record this formula on your capture sheet. Let's take a moment to reflect on three important relationships between the measures of arcs and angles formed by secant lines. As we do, pause the video as needed to complete the graphic organizer on your capture sheet. We see that when two lines intersect inside a circle, the angle formed is equal to half the sum of the measures of the intercepted arcs. And when the lines intersect outside the circle, the angles formed is equal to half the difference of the measures of the intercepted arcs. And when the lines intersect on the circle itself, the measure of the angle is exactly equal to half the measure of the one intercepted arc. Such an angle was called an inscribed angle. And of course, remember that when the vertex of the angle is exactly in the center of the circle, forming a central angle, the measure of the angle is equal to the measure of the intercepted arc. Let's try two examples. Take a moment to pause the video here and try to apply the formulas you have learned to these two diagrams. In the first problem, point G is in the interior of the circle, so 2x is equal to 120 plus 40, or the value of x is found by adding the arc measures and dividing by 2, giving 160 divided by 2, or 80. Did you get it right? In the second problem, the intersection is outside the circle, so 2x equals 82 minus 26, meaning x is equal to 82 minus 26 divided by 2, which gives us 56 divided by 2, or 28. I hope you got them right. Let's try one more example. This time, we are given the measures of one vertical angle and an intercepted arc, and we need to find the measure of the other intercepted arc. Pause here and try the problem yourself on the capture sheet. Since the lines intersect inside within the circle, we know that twice the measures of the two vertical angles equals the sum of the measures of the intercepted arcs. So 55 plus x equals 2 times 60. Or 55 plus x equals 120. And we find that x is equal to 65 degrees. And with that, you now know how to describe the mathematical relationships between angles formed by intersecting lines and the arcs they intercept, whether the lines intersect inside the circle or outside the circle. And you can use that relationship to solve for missing angle measures.